Have you ever wondered how your phone knows exactly where you are? You're driving, walking, or even just sitting on your couch, and that little blue dot on the map is right there with you. It seems like magic, but it's actually a fascinating system called GPS, which stands for Global Positioning System. Today, we're going to pull back the curtain and demystify this incredible technology that we use every single day. So, buckle up, because we're about to take a journey from outer space right down to the palm of your hand. First things first, what exactly is GPS? At its core, it's a satellite-based navigation system. Imagine a constellation of satellites orbiting the Earth, constantly sending out signals. These aren't just any satellites. There are at least 24 of them, and usually more, zipping around our planet twice a day at about 14,000 kilometers per hour. Think of them as a network of celestial clocks, each one broadcasting its precise location and the exact time down to Earth. This network is owned and operated by the U.S. government, specifically the Space Force. But here's the cool part, it's available for anyone with a GPS receiver to use, for free. And that little receiver, it's built right into your smartphone, your car's navigation system, and even your smartwatch. So, how does your phone use these signals to pinpoint your location? It all comes down to a really clever bit of math and physics, a process called trilateration. Now, don't let the fancy word scare you. The concept is actually quite simple. Imagine you're lost in a huge, flat field. If someone tells you you're exactly 10 kilometers from town, that doesn't fully help. You could be anywhere on a circle with a 10-kilometer radius around town. Now, what if another person tells you you're also 15 kilometers from town B? Suddenly, things get more interesting. You now have two circles, and they intersect at 2 points. This narrows down your possible location to just 2 spots. That's a big improvement. To find your exact spot, you just need one more piece of information. If a third person tells you you're 8 kilometers from town C, that third circle will intersect with one of the 2 previous points. And voila! You've found your exact location. GPS works on the same principle, but in 3 dimensions. Instead of circles on a flat field, we're dealing with spheres in space. Each satellite is like one of those towns. When your phone receives a signal from a satellite, it can calculate its distance from that satellite. How? Well, the signal travels at the speed of light, which is a constant. The satellite's signal contains a timestamp of when it was sent. Your phone's internal clock notes the time it receives the signal. By subtracting the send time from the receive time, your phone knows how long the signal took to travel. Distance equals speed multiplied by time. So, your phone just multiplies that travel time by the speed of light, and bam, it knows how far away it is from that satellite. So, with one satellite, your phone knows it's somewhere on the surface of a giant, imaginary sphere with that satellite at its center. Just like our field example, that's not enough. So, your phone listens for a second satellite. Now it knows it's on the intersection of 2 massive spheres, which creates a circle. Getting warmer. Then, it picks up a third satellite. The intersection of that third sphere with the circle created by the first 2 gives you 2 possible points. You might be thinking, but my phone knows my exact location, not 2. And you're right. So how does it choose the correct one? Often, one of those 2 points is a ridiculous answer, like a location thousands of miles up in space or deep inside the Earth. Your phone's software is smart enough to discard the impossible option. But there is an even more elegant solution that also solves another huge problem, the problem of time. This is where the 4th satellite comes in, and it's absolutely crucial. Remember how this all depends on precise timing. The satellites have incredibly accurate atomic clocks on board, but your phone, not so much. The clock in your phone is a simple quartz clock, similar to a digital watch. It's good, but it's nowhere near as precise as an atomic clock. Even a tiny error, a millionth of a second, could throw off the distance calculation by hundreds of meters. Your location would be wildly inaccurate. So, How does GPS solve this? By using a fourth satellite, your receiver can solve a fourth unknown variable, the exact time. Think of it as a small algebra problem. You have 3 unknown variables for your location: latitude, longitude, and altitude, and 1 for the time error in your phone's clock. With signals from 4 different satellites, your receiver gets 4 distance equations. With 4 equations and 4 unknowns, it can solve for all of them simultaneously. It calculates your precise 3D position and corrects its own clock to be perfectly in sync with the super-accurate atomic clocks in space. It's pure mathematical genius. So, to recap, your phone needs to see at least 4 satellites to get a reliable position. It measures the time it takes for signals to travel from each of those 4 satellites. Using these time measurements, it calculates its distance from each one. Then, through trilateration, it solves for its latitude, longitude, altitude, and the precise time. All of this happens in a fraction of a second, constantly updating as you move. But wait, there's more. The journey of that satellite signal isn't always a straight, clear shot. As it travels from space, it has to pass through Earth's atmosphere, specifically the ionosphere and the troposphere. These layers can bend and slow down the signal, just like light bending through a glass of water. This creates delays and introduces errors into the distance calculation. To combat this, the GPS system has gotten even smarter. There are ground stations all over the world constantly monitoring the satellites and the atmospheric conditions. They calculate the current signal delays and send this correction data back up to the satellites. The satellites then include this correction information in the signals they broadcast. So, your phone receives not just the time and location of the satellite, but also data to help it compensate for atmospheric distortion. This makes the final location calculation much more accurate. Furthermore, your smartphone doesn't rely solely on GPS. It uses a hybrid approach called Assisted GPS, or GPS. When you first turn on your phone's location services, it can take a while to find and lock onto 4 satellite signals. To speed things up, your phone uses cellular networks. It can get a rough estimate of its location from nearby cell towers. It can also download the satellite almanac data about where the satellites are supposed to be over your Wi-Fi or mobile data connection. This is much faster than waiting to download it directly from the satellites. This assistance gives the GPS receiver a head start, allowing it to find your location in seconds rather than minutes. And that's not all. Your phone also uses other sensors to refine your position, especially when a GPS signal is weak or unavailable, like inside a building, in a tunnel, or in a dense urban canyon where skyscrapers block the view of the sky. Your phone's accelerometer can detect movement and changes in direction. The gyroscope measures rotation. The magnetometer acts as a digital compass, telling you which way you're facing. By combining all this data, a process called sensor fusion, your phone can continue to estimate your position and movement even when it loses contact with the satellites. This is why the blue dot on your map keeps moving smoothly through a tunnel, even though there's no way a satellite signal could reach it. So, the next time you use Google Maps to find the nearest coffee shop, or track your run, or see where your food delivery is, take a moment to appreciate the incredible dance of technology happening behind the scenes. It's a symphony of atomic clocks, orbital mechanics, special relativity, atmospheric science, and clever mathematics. A constellation of satellites orbiting thousands of kilometers above us, talking to a tiny receiver in your pocket, all working together to place that little blue dot perfectly on the map, guiding you on your way. It's one of the most amazing, and yet most taken for granted, technologies of the modern world. Thank you so much for joining me on this deep dive into the world of GPS. I hope you found it as fascinating as I do. If you enjoyed this video and learned something new, please give it a thumbs up and consider subscribing for more explorations into the tech that shapes our world. Let me know in the comments what other technologies you're curious about. Until next time, stay curious.